Module 7, problem number 5. A pediatrician wants to determine the relation that may exist between a child's height and head circumference. She randomly selects 5 children and measures their height and head circumference. The data are summarized below. Complete parts A through F below. So here's our data set. As you see here, that top row is our X, are the X variable, are the X values, and that's the height of the children. And then the right below that's the head circumference. That's the Y, the dependent variable. And there's all the head circumferences. Part A, treating height as the explanatory variable X, use technology to determine the estimates of beta naught and beta 1. So we're going to open our data set in StatCrunch. We're going to go to Stat, Regression, Simple Linear, X. Select our X variable and our Y variable, and we're going to click Compute. Open that up to see it all. So as you see here, we've got our estimates right here. Here's our intercept and here's our slope. That's our beta 1 and beta naught. So let's go ahead and plug those in, rounding to 4 decimals. So our intercept there is 10.8690, looks like, and our beta 1 or B1 is 0.2429. Oops, let's round that up to 30. 243, yep, 30. Check answer. Good job. Part B, use technology to compute the standard error of the estimate. Well, wouldn't you know, we already have it right here. And if you saw from the lesson this week, that I took one of these screenshots and broke down where you can find all these results without having to rerun them or figure it out. So our standard error of the estimate is right here. Estimate of standard error. Isn't that nice? So we're going to round to 4 decimal places. That's 0.0601. Once we round up, check answer. Well done. Part C, a normal probability plot suggests that the residuals are normally distributed. Use technology to find the standard error of B1. So B1, remember, is your slope. So we're going to go to slope and go over to standard error. So we have it right here. Round to 4 decimal places. That's going to give us 0.0244. 0.0244. Check answer. Nice work. Let's click continue. Part D, a normal probability plot suggests that the residuals are normally distributed. Test whether a linear relation exists between height and head circumference at the alpha equals 0.01 level of significance. State the null and alternative hypotheses for this test. So remember, in this case, we're testing to see if the slope is equal to 0 or if it's not equal to 0 in this case. Basically the correlation coefficient. So we're looking at beta 1. So that means our null hypothesis is that beta 1 is equal to 0. Our alternative is that beta 1 does not equal 0. So that would be option D. Check answer. Good job. Determine the p-value for this test. Well, what do we have here? We already have a p-value. So we go to slope. Since we're looking at B1, we're going to go all the way over to p-value. We need 3 decimal places, so we're going to go 0.002. 0.002. Now our alpha is 0.01. First, let's go ahead and check our answer. Well done. All right, so our alpha is 0.01. So since our p-value is less than alpha, we know that we're rejecting the null hypothesis. So that gives us option C or D. So let's start reading through C to see if that works. Reject H naught and conclude that a linear relation exists between a child's height and head circumference at the level of significance alpha equals 0.01. That is true. I just want to show you the difference here. It says conclude that a linear relation does not exist. Remember, in this case, our alternative is that the linear relation exists. So let's check our answer. Fantastic. Use technology to construct a 95% confidence interval about the slope of the true least squares regression line. So we're going to go back to StatCrunch. We go to Stat, Regression, Simple Linear, select our X and Y again. And we're going to click confidence level here. It says 95%. It's already at 95, so let's just click compute. As you see, the results are very similar. Instead here of having a p-value, though, now we've got our upper and lower limits. So let's scroll down. We're looking for the interval about the slope. So we're going to use this bottom row right here. Our lower bound, rounded to 3 decimals, is 0.165. And our upper bound is 0.321 once we round up. Check answer. Fantastic. Part F, suppose a child has a height of 26.5 inches. What would be a good guess for the child's head circumference? So in this case, we're going to just plug this right back into our equation right here. But now we're going to use our numbers so we have 26.5 is what we're trying to predict. We're going to use our numbers from up here. So remember, when we say that now let's look at our equation. Our equation is y hat equals 0.2430 times x plus 10.8690. That's just a simplified way of writing this. So we're going to plug in that 26.5 in for x. Okay, so let's go back down here. I'm going to use the calculator. We're just going to write 0.240, 30, and we're going to multiply that by 26.5. And then we're going to add 10.8690. And that gives us 17.3085. What do we need? 2 decimal places. So that gives us 17.31. Check answer. Excellent. So that's how you run the hypothesis test, do the confidence intervals, and then use that model to predict a certain value. If you have any questions about that problem, let me know, or anything else.